Welcome to Metrology lecture series. In the present video, we will discuss the errors in measurement. While taking physical measurements, the values obtained are not perfectly accurate because every measurement has some uncertainty. In this regard, we have to properly analyze the measurement data and understand what are the errors are involved and how much error is involved. The errors in measurement is the difference between the measured value and the true value of the measured dimension. So errors in measurement equal to the measured value minus true value. The error in measurement may be expressed either as an absolute error or as a relative error. First we will discuss the absolute error. Absolute error is the difference between individual measurements and true value of a quantity. Let's consider A1, A2, A3 up to the AN are the individual measurements. Then mean value of these measurements is the A1 plus A2 plus A3 up to the AN divided by N. Here N is the number of individual measurements. So this A mean we can be written as summation of I equal to the 1 to N AI divided by N. Then this A mean equal to the true value of a quantity. So next we have to look for the absolute error in the individual measurements. That is so absolute error in each measurement is, so first we have to consider the first individual measurement, that is the A1. So absolute error for the first individual measurement is the delta A1 equal to the A1 minus A mean. Similarly for the absolute error for the second individual measurement is the delta A2 equal to A2 minus A mean. Similarly absolute error for the AN is the delta AN equal to the AN minus A mean. So mean value of this absolute error of the individual measurements is the delta A mean equal to the delta A1 plus delta A2 plus up to the delta AN divided by N. Here absolute error for the each individual measurement is considering the positive only. Then delta A mean we can be written as delta A mean equal to the summation of I equal to 1 to N delta AI divided by N. Then absolute error will become the delta A mean minus A mean. So next we have to look for the relative error. So relative error is the ratio of mean absolute error to the mean value of the quantity. So relative error equal to the delta A mean divided by A mean. So next we have to look for the types of error. During measurement, several types of error may be arise. These are the first one is the static error. Second one is the instrument loading error. Third one is the dynamic errors. These static errors we can be subclassified as the reading errors, characteristic errors and environmental errors. Similarly, dynamic errors are classified as the systematic or controllable error and the random or uncontrollable error. So first we have to discuss about the static errors. First we will look for the static errors. Static errors result from the physical nature of the various components of measuring system. There are the three basic sources of static errors. Static error divided by the measurement range gives the measurement precision. Static errors are the subclassified is the three types. So first one is the reading errors. So first we have to discuss about the reading errors. Reading errors apply exclusively to the readout device. These do not have any direct relationship with the other types of the errors within the measuring system. So these reading errors are the two types. First one is the parallax error. Second one is the interpolation error. So I have to look for the parallax error. Parallax error is a measurement error that happens when the scale is read from the side instead of the straight in front of the pointer or a mark. Because of this slanted view, the reading looks different from the actual value. So how to avoid these parallax errors means, always you have to keep the eye directly in line with the pointer and the scale. Moreover, you have to use the instruments with mirror scales, which is align the pointer with its reflection. And also prefer digital instrument which eliminate the parallax error. So next we have to look for the another type of the readout errors, that is the interpolation error. Interpolation error is a reading error that occurs when it is difficult to judge the exact position of the pointer between the two nearby scale markings. And how accurately a scale can be read depends on the thickness of the scale lines and the spacing between them and thickness of the pointer. Moreover, this type of error can be reduced by increasing the scale size or using a magnifying glass near the pointer or using a digital display. So next we have to discuss about the characteristic error. It is the difference between the actual reading given by a measuring instrument and the value that is expected to give according to theory or its specified performance. So linearity error, repeatability error and hysteresis error and resolution errors are the types of characteristic errors when the theoretical output of an instrument is a straight line. Moreover, calibration error is also considered a characteristic error. So let's see the example of this characteristic error. In a dial gauge, the spring inside may not be perfectly elastic. Because of this, when the plunger moves up and down, the point may not return to its exact same position. This causes a small and repeatable error in the readings, which is the characteristic error of the instrument. Next we will discuss the another type of the static error, that is the environmental errors. These environmental errors are result from the effect of surrounding such as temperature, pressure, humidity, etc. on measuring system. Moreover, external influences like magnetic or electric field and nuclear radiations and vibrations or shocks, etc. also leads to environmental errors. And environmental errors of each component of the measuring system make a separate contribution to the static error. And it can be reduced by controlling the atmosphere according to the specific requirements. So next we have to discuss the another type of the error, that is the instrument loading errors. Loading error occurs when the quantity being measured changes because the measuring instrument is applied to it. So in the simple words, the value changes after the instrument come into contact with the object. Instrument loading error is the difference between the value before and after the instrument touch the object. For example, when the soft or delicate part is measured, it may get slightly deformed due to the pressure applied by the measuring instrument, which leads to a leading error. Moreover, so these type of the instrument loading errors cannot be completely avoided. So the measuring instrument should be chosen carefully to minimize the loading error for the given measurement. So next we have to look for the another type of the error, dynamic errors. Dynamic error is a measurement error that occurs when the value being measured changes with respect to the time. So it happens because the measuring system cannot respond quickly or accurately to these changes. So this error is caused by the factors such as the inertia, damping, friction, or limitations in the sensing or display system. These dynamic errors can be broadly classified into two categories. One is the systematic error and the random errors. So systematic error are the controllable error and random errors are the uncontrollable error. So first we have to discuss about the systematic errors. Systematic errors are regularly repetitive in nature. They are of a constant and the similar form. So these errors occurs due to incorrect conditions or methods which are repeated in the same way every time. So among these systematic errors, all error except the personal error do not depend on the observer, and personal error changes from one person to another person. Other systematic errors can be controlled in size and condition if they are properly analyzed. They can be identified and reduced also. Moreover, they are also called as the controllable errors. So first we have to see the different types of the systematic errors, which include the first one is the calibration error. So calibration errors happen when the scale of a measuring instrument is not exactly correct. For example, the actual size of standards like slip gauges or engraved scales may differ slightly from their given value. So this causes the same error to appear in every measurement. Also, effects such as instrument inertia or hysteresis may stop the instrument from measuring accurately. So moreover, in electrical instrument, a voltage drop in the connecting wire also can create an error in measurement called as a transmission error. So next we have to look for another one is the ambient or atmospheric error. So variation in atmospheric conditions such as temperature, pressure and humidity at the place of measurement compared to the standard conditions, and these can cause the errors in measurement. So measuring instruments are calibrated under these conditions. So if the actual conditions are different, error may occur in the measured size of the component. So among these factors, temperature is the most important parameter because it causes expansion or contraction of either the component being measured or the measuring instrument, leading to a measurement error. So next we have to look for the stylus pressure. Another common source of the error is the pressure applied to the workpiece during the measurement. Although this pressure is usually small, it can still cause a noticeable deformation of both the stylus and the workpiece. So ideally, the stylus should not just touch the workpiece. In addition to deformation, stylus pressure can also cause deflection of the workpiece. Similarly, variation in the force applied by the anvils of a micrometer lead to different readings. So in such cases, the error occurs due to the distortion of both the micrometer frame and the workpiece. So next type of error is avoidable error. These errors occurs due to the mistakes that can be prevented during the measurement. These avoidable errors include the parallax error and improper alignment of the workpiece centers and incorrect placement of measuring instrument, such as keeping a thermometer in direct to sunlight while measuring the temperature. So these are all the including the avoidable errors. And moreover, misalignment error occurs when the center line of the workpiece is not perpendicular to the center line of the measuring instrument. So next we have to look for the another type of the dynamic error, that is the random or uncontrollable error. So random errors are the irregular and do not follow a fixed pattern, and they occur by chance and accidental in nature. These errors are the inherent in the measuring system, are difficult to eliminate completely. So the exact cause, size and the source of the random errors cannot be identified clearly from the measuring system or the measurement conditions. And let's see the possible sources of the causes of random errors. So small variations in the position of the setting standard on the workpiece, it may be causes for the random error. Another cause is the slight movement of lever joints in measuring instrument and mistakes by the operator while reading the scale, and moreover is the chances in friction with the measuring instrument. So these are all the causes for the random errors. Next we look for the differences between systematic and random errors. Systematic errors are the not easy to detect, but random errors are the easy to detect. Systematic errors cannot be eliminated by repeated measurements, but random errors can be minimized by repeated measurements. Systematic error can be assessed easily. Random errors, static analysis is required. Minimization of the systematic errors increases the accuracy of measurement. Minimization of random errors increases repeatability and hence precision of the measurement. Calibration helps to reduce these systematic errors, but in the random errors, calibration has no effect. Systematic errors characterization is not necessary, but random errors characterized by mean, standard deviation and the variance. In the systematic error, reproducible inaccuracies that are consistently in the same direction, but in the random error, random in nature and can be both positive or maybe the negative. So this is the errors in measurement, and thank you.